Rachel Patton, a science teacher from Colorado, and I'm with you today to walk you through the first 3 days of the first lesson of the C.2 unit of OpenSciEd. It's possible you only missed one of these days, and if so, you can use the chapters features in YouTube to find the day you missed. But I'm going to start at day 1. There's a few resources that you will need today. You'll need your science notebook or a piece of paper to write on if you don't have your science notebook with you. There are several links here that you will need. Don't worry about opening these links now. You'll see them again when you need them in the lesson. So the first thing I want you to do is, as you watch this video of lightning, just think to yourself and jot down some notes maybe of what you see happening, and think about where you see the lightning coming from and where you see the lightning going to. Right? If you are still writing down your thoughts, you can pause this video here while you finish writing down your thoughts. And the next thing you're going to do is make yourself a T-chart like the one you see here on the slide, a notice and wonder chart. And on this notice and wonder chart, you're going to record your noticings and your wonderings as you watch this slow motion video of lightning that's playing on the slide here. The video will replay automatically. And if you need to pause the video to give yourself more time to record your noticings and wonderings, feel free to do so. And here is a second slow motion video of lightning. So keep recording your noticings and your wonderings on that same chart. Again, if you need to pause here to take some more time to write your noticings and wonderings down, feel free to do so. This lightning video will replay automatically. So if you were in class, this would be a turn and talk, but you don't have a partner to turn and talk with at home likely. So instead, just record your thoughts in your notebook. So you're going to answer these 3 questions. What do you know about lightning? What stories, family history, or mythology have you heard about lightning? And you can really think about anything there. You can think about stories from popular culture, fiction or nonfiction books that you've read, anything from your religion or culture that has to do with lightning. And then think about how these stories help us make sense of lightning and its role in the world around us. And pause the video here to give yourself time to record your thoughts before you move on. Now you have the opportunity to read some other stories about lightning. In class, you would be in a group of 4, and each of you would have one of these to read. So just pick one. 2 of these have a video that goes along with them. So the first is a reading about Navajo beliefs on lightning. That one looks like this. So if you open that bit.ly that's on the slide, you'll see this doc, and then there's a link to the video on the doc. So you can watch the video as you follow along with the transcript. The same is true for the lightning stories Oyo. And then there's also a reading about lightning in mythology and several inventors and their connection to lightning. So again, pick one of these 4. You can pause the video and type this link into your browser. Remember, these links are case sensitive. So this first one, that's bit.ly/Navajo transcript, make sure the N and the T are capitalized. And as you're reading whichever of these 4 you choose, answer this question in your notebook. How does the story explain lightning? In what ways are matter or energy part of the story? So pause here while you read whichever of these 4 you choose. And if you choose to read more than one, you can answer these questions yourself about similarities and differences between the stories. If you didn't, which is totally fine, when you get back to class, ask some classmates about the stories they read so you can get a sense of some of the similarities and differences. And now we're going to shift gears a little bit, and we're going to look at some data related to lightning. So this is the first data you're going to examine, these 3 graphs that are on the slide. Notice the y-axis for all of them is millions of flashes. And then the x-axis is seasons, months, or weeks of the year. So take a moment, pause here, and answer these 3 questions in your notebook. What do each of these graphs show? What patterns do you notice across the graphs? And what questions do you have about this data? So pause the video here so that you can examine these graphs more slowly and answer these questions in your notebook. Here's some more data about lightning in the United States. If you want to look at this map in a little more detail, this link here will take you to this map. And also on this link, in addition to the map, there is some data. So you can see total lightning events broken down by state. And then you can also see lightning events by area. So that would be lightning per square mile in each state. So if you want to take a moment to look at this more closely, you can do that. You can pause here. And then keep adding to the same notice and wonder chart that you made before. Or if you ran out of space, feel free to make a new one. But just add your noticings and wonderings about this lightning data. Pause here to give yourself some more time. And then we will look at some more data. So this is a map of the world that also has rates of lightning. So mean lightning flash extent density, which is the number of flashes visible per 100 square kilometers per day. This yellow line that goes across is the equator. And then notice there are several deserts that are labeled on this map as well: the Gobi Desert, Arabian Desert, Sahara Desert, and Atacama Desert. So take a moment, examine this map, keep adding to your notice and wonder chart. The next thing we're going to consider is some of the impacts of lightning strikes. So before we look at that, I want you to think to yourself or jot down some ideas about why it might be helpful or important to consider these impacts. lightning damage and lightning fatalities specifically. And then also keeping in mind that considering these types of data can be stressful. You and your classmates and your friends all have different experiences. So think about how someone's personal experiences might impact how they view this data or how this data affects them, and think about how we can be helpful to each other and supportive of each other when we are considering data like this. So this is just some information about injuries. So in the United States, there are 400 lightning-related injuries each year. Of those that are injured, up to 74% may have a permanent disability as a result of that lightning injury. And worldwide, lightning is responsible for 240,000 injuries approximately each year. This map is showing you lightning fatality in the United States. So notice there's some color coding. You have a key over here on the bottom right that tells you what the darkness of the colors indicate about the numbers of lightning fatalities per state. So you can keep adding to your notice and wonder chart as you look at this map. And you can pause here if you want to take a closer look at the map. Here are those three maps again, if you just want to take another look at them. And then also, in addition to your noticings and wonderings, answer these questions in your notebook. What factors seem to influence where or when lightning occurs? And how does looking at different data and different scales help us to think about lightning? If you need to go back and look at those graphs again, feel free to pause or rewind the video a little bit. We'll pause here and answer these two questions in your notebook. Here is some patterns and noticings from another class. So some of these ideas may not be ideas that you thought of. You may not see your ideas on this list. And when you return to class, your class list may look different than this. So make sure that when you return to class, you look at the list that your class came up with as well. But here are some of the patterns and noticings that another class came up with. There seems to be more in the summer. There seems to be a lot of lightning near coastlines, but then also in the central US. Florida seems to have a really high density of strikes, which might be related to its coasts. But then there's seems to be really low amounts of lightning strikes on the West Coast. There were some wonderings about if water, wind, elevation, and or temperature, like what roles those factors played in lightning. There seems to be more along the equator. At temperate and tropical areas, there seems to be very little lightning at the poles, and also very little lightning in North Africa and Europe. Here are the important factors that this class came up with for things they think influence the amount or the rate of lightning: water, temperature, location, elevation. They wonder if metals. So they knew something about not golfing when there was lightning, so they wondered if metal played a role. And then also they wondered about buildings, the number of buildings or the type of buildings, and if that played a role. This is the end of day one. So if day one is all you missed, you can stop here. And if not, we're going to move on to day two. If you also missed day two, or if day two is the day you missed because you were present for day one, here's where we are going to go through day two. So make sure you have the resources that you need. You'll need your science notebook or a piece of paper to write on if you don't have your notebook with you. And you will need this bit.ly link for your initial model. You don't need to open it now. You'll see the link again when you need it. So first, take a moment to remind yourself what we figured out about lightning last class. Think about the data you examined, the story or stories that you read and talked about, and what sort of questions came up for you from those stories or the videos or the data. And then think about why scientists like us use models when thinking about phenomena like lightning. Remember that models help us predict or explain, and think about why it's important to include all of these things here: the components of a model, relationships or interactions between components, and also mechanisms. So in your notebook, think about what sort of components you might need to include in a model that answers the question, what causes lightning to strike at a particular place and time? And then use this bit.ly link, type this into your browser to open the initial model handout. If you want to work on this handout, you'll need to make yourself a copy of this document, and you can type in it. You can use Google Draw to make a model if you wish. You should also feel free to just do this on a piece of paper if that's simpler for you. So you'll list the components that you brainstormed. And then here is where you're going to create your model to answer the question, what causes lightning to strike at a particular place and time? And then here you want to include like a zoom in of the lightning. So if we could zoom way, way, way in on a bolt of lightning, what would we see? And then there's also a second page. Consider some of the factors that we thought about that we think impacts lightning. Remember the list that we saw in day one, either in this video or your class's list from day one. Pick one of those factors and write it on this line. And then try to answer that question. How do you think this factor impacts differences in lightning strikes, lightning damage, or lightning fatalities in different locations? So again, you can use this bit.ly link to open the model handout and make a copy and work from that model, or you can just use the model handout as a reference and work on your own piece of paper. Make sure that when you are making your initial model, you are including relationships or interactions between components, and try also to include some mechanisms to help answer that question. So take a moment, pause the video here, and take several minutes to work on that model, and then resume the video once you have finished your initial model. Now that you have your model made, take a moment and think about these questions and jot down your ideas in your notebook. Is lightning energy, or is lightning matter? What evidence do you have for either? What evidence do you have that lightning is matter? What evidence do you have that lightning is energy? And how might answering these questions help us figure out what causes lightning? So pause here and answer these questions in your notebook. And then when you're done, resume the video so you can move on. Now that you've answered those questions, take a moment to brainstorm how you think energy and matter are involved in a lightning strike. What role do they play? Why are they important? How do they make lightning what it is? And then go back and revise your model. And you want to revise it based on these two suggestions. You want to show two places in your model where particle level changes are happening in the lightning system. And you want to use energy transform models like the energy transfer models we used in C1, to show two energy transfers that occur during a lightning strike. So again, pause here so that you can go back and revise your model. If you were in class, you would be doing a gallery walk and looking at several other models. There are two models you're going to look at today. So make yourself a T-chart in your notebook, like the one you see here, similarities and differences. And then you will use this T-chart to record similarities and differences between your model and the two models you're going to observe. Here's the first model. You can pause the video while you compare models and record similarities and differences. Here's the second model. Again, you can pause here while you record similarities and differences. This is the end of day 2. So if you only missed day 2, you can stop here. Or if you also missed day 3, we're going to continue on to day 3. So here's day 3. So if day 3 is the day you missed, or day 3 is one of the days you missed, here's where we will continue to work through day 3 of lesson 1. So last class, you made an initial model and you did some gallery walks to observe other initial models. So now we're going to make a consensus model. If you were in class, you would be talking with your teacher and your classmates and spending a lot of time sharing ideas and finding consensus on these models. Here is just one example from another class of an initial consensus model. Like the other class artifacts you've seen in this video, your class initial consensus model may look different from this. So you may or may not see your ideas or ideas from other models you saw represented in this consensus model. When you return to class, make sure that you take a good look at your class's initial consensus model. In this consensus model, we have a tree, we have clouds, and we're wondering if it has to be a certain type of cloud. We have warm air with lots of energy. We have some particles and energy in our cloud. And then here we have lightning striking a tree and also a lake. In our zoom in, we have both matter and energy. So we have some arrows showing us energy transferring from matter. And we're wondering if this is air or electricity. Down here at the bottom, we have our energy transfer model of energy transferring from cloud to air and also to ground and to water. And we have some ideas about that energy, but we also have some questions. So now that we have our initial models, think about some related experiences that you may have had. So in your notebook, think about when and where you have experienced or seen someone experiencing lightning or something similar to lightning. So if it's something that you think might be connected or related, have the same types of matter and or energy involved. And then what signals do you use to decide to protect yourself against a storm? And how does where you are determine how you stay safe? So where might you go to stay safe? And how might that be impacted by where you are at a particular time? So pause the video and record these ideas. And here are some related phenomenon that another class came up with. Again, you may or may not see your ideas represented here. Make sure when you return to class that you take a look at your class's list of related phenomena. Pause here so that you can read some of these things related to lightning, when and where it strikes, or what are some other things like lightning? And then also, how do people protect themselves from lightning? So pause here and give yourself time to read over this list. Now we're going to develop our driving questions board. If you are in class right now, you would potentially be talking with your classmates and have a sticky to write on. If you have a sticky to write on and want to write a question on it, feel free. Otherwise, just record one or more questions in your notebook about lightning. So think back to everything you've seen, the videos, the data, your initial model, the initial consensus model, those related experiences, and write down one or more question you have about lightning. You can pause here if you want to give yourself a little more time to think and record your questions. Here is a driving question board from another class. So take a moment and read over these questions. If this helps you think of other questions you have, feel free to record those in your notebook. Make sure that when you return to class, you take a look at your class's driving questions board. And pause here if you want a little more time to read over these questions. Take a moment and think about what sort of investigations we could do to help us answer all of the questions that we came up with about lightning. Think about what sort of data you might need. Record those ideas in your notebook. Pause here if you would like to give yourself some more time to think and record your ideas. Here is a list that another class came up with for some ideas for investigation. Remember, your ideas you may not see represented here. These may be some things that you didn't think about. Make sure that when you return to class, you take a look at your class's list of ideas for investigation and possible data. One thing, just to sort of clarify some language, when you think about a lightning flash versus a lightning strike, here's some information to sort of help you differentiate those two terms. So everything in this picture is a lightning flash. And then where you see these yellow circles, where the lightning hits something, that's what we're referring to as a lightning strike. And finally, if you have your notebook with you and you want to take a moment to organize your notebook to get ready for this next unit, feel free to do so now. Here are some suggestions for how to organize your notebook. You can pause here to read over this more thoroughly if you need to. If you need to go back and look at anything from this lesson, feel free to rewind the video to look back at other parts of the lesson. Otherwise, this is the end of lesson 1 of the OpenSciEd unit C2.